Let's talk about components. Everything in your scene is a game object, and it is the components we attach that make them different. Select the directional light. Note that we have a transform common to all game objects, but below that we have a component called light, which provides a list of properties that control how the light will behave. Now, if we go into our hierarchy view, right-click, and go to Create Empty, we now have an empty game object, which has no components. At the bottom of the inspector is the Add Component button. If we press this, it's going to list all of the various components we have access to inside of Unity. And if you want to, you can spend time searching through this list. However, if you know generally what the kind of component you want is, you can also type it, such as light. Here we can see 3 different components with the word light in it. Let's go ahead and press the top one, light. We have now added a light component to this game object. Every game object that you see within this list can be created by making an empty game object and attaching the necessary components to it. This is just a faster, pre-assembled way of creating certain game objects. Let's now create a 3D model and see what makes that different from these other game objects we already have in our scene. Go ahead and go to GameObject, 3D, and Sphere. Here we can see that a sphere is actually a combination of several different components. We have a sphere mesh filter, a mesh renderer, and a collider. The mesh filter is going to generate the data that is the structure of a sphere. Without it, Unity wouldn't know how to actually build the sphere. The mesh renderer controls rendering the object, that is, displaying it on the screen. It has a tick box here that if you disable, you'll notice causes it to turn on and off in the viewport. Then we have the collider, which is used by the physics system to represent that object. Now don't be confused by the material slot down here. A material is not a component. Now let's go back to our game object that was blank but now has a light. We can also remove components as we wish. Press the ... on the side and click on Remove Component. If we wanted to create our own custom component, we do so by creating a C# script. C# is the language we'll be using to write it. Go ahead and click Add Component. Now if you want to, hit the X to get rid of your search query. But regardless of whether or not you have words in the search that are narrowing what you're looking at, or if you have the entire list, at the very bottom it will always say New Script. Click on that. It's going to ask you to name that script. For now, since we're just testing things, why don't we call it Test, capital T-E-S-T. What's important to understand is that the name of the script needs to match the name of the class inside the script. And classes cannot have spaces. And if you're following convention, all classes begin with a capital letter. So let's do that as well. Now click Create an Add. Now what you'll notice is if we click the Assets folder that we have a new script called Test with a sharp icon next to it. Usually we want to put scripts in their own folder, so why don't we go ahead and create one by right-clicking, going to Create, and Folder at the top. Name this Scripts. Drag and drop Test into the new folder. Many times, in order to organize things, we will use an underscore to keep certain parts at the top of our list. For instance, if I press on Scripts and hit F2 to rename it, and I can put an underscore at the beginning, and alphabetically it will now be at the top of my list. You don't have to do this, but if you have a very important folder in the future, this is a great way of keeping it at the top of your hierarchy and easy to access. Double-click the scripts folder, and you'll see the test file. In the inspector, it will show you the code right over here. Now, if we want to edit this code, that is, add actual functionality to this, we're going to need to use a different editor. But first, why don't we make sure we have the right editor selected for Unity to develop with? Go to Edit and then Preferences. Then go to External Tools, and here at the top is External Script Editor. You'll notice that I have it set to Visual Studio 2019 Community Edition. This should have been automatically installed with Unity if you didn't have it already installed before. If you click on the drop-down, you'll notice that there are other versions of Visual Studio that I can use, and that's because I have these installed on my computer. I'm going to be using Visual Studio 2019. Once you've made sure you've selected the right program, go ahead and close this window. If you double-click on the script now in our project folder, it will open up Visual Studio. Now I have a separate PowerPoint file on the course Canvas page that explains loosely the C# language. We're not going to go into everything about C# in class and in these videos though. You can deal with learning what a for loop is, or an if statement, or Boolean values, and so forth. That's all common programming practice you should already know. Now C# is similar to C++ or Java. Now at the top is the using keyword. It is used to import in types and create aliases for other namespaces. The system.collections and systems.collections.generic are a special set of classes that hold objects. Using Unity Engine provides all the Unity-specific functionality that we need to make Unity do interesting things. So you're always probably going to include those three. Below that is our class declaration. This is where we're saying we have a public class, public meaning it can be seen by others and used by others, as opposed to protected or private. Then we have class, saying that this is a class definition. We are building this object, the blueprints, so to speak, of this object. If you're not familiar with object-oriented programming, classes, instances, and so forth, then go ahead and take a look at those PowerPoints that I provided. Next, we have the name of the class. And as I mentioned, this name needs to match the script name exactly. One of the most common errors you'll get is if someone renames this. For instance, a very popular thing for students to do, especially when they don't follow conventions, is to make this one a lowercase and then save it. They'll go back over into Unity, and it takes Unity a second, and then you might end up running into some sort of a glitch or an error. So for instance, here we have test, and what I'm going to do is actually open up my console over here, and I'm going to go ahead and just hit run. Here I get a couple different warnings. The reference script test on this behavior is missing. The reference script on this behavior, GameObject, is missing. Why can't it find it? Well, because it's named test and it's looking for a test with a capital letter. You might say, I don't understand what this is trying to tell me. Don't worry. What's important to note is that if you double click on any of these, it will take you to the problem area. I double clicked on it, it automatically selected the GameObject and showed me the script. And what does it say? The associated script cannot be loaded. Please fix any compile errors and assign a valid script. Go ahead, double click it, come back here, change the little t to a big T and hit save or Control S. Come back over to Unity, we'll hit clear to clear out anything, and I'm going to go ahead and hit run again. And I didn't get any errors or warnings or anything else in this console. Now, nothing happened, and that's because this is a basic script with no real functionality yet. Let's jump back into Visual Studio. Next up is this thing called monoBehavior. We have a colon and then monoBehavior. We are inheriting from the class monoBehavior, which is a built-in class in Unity that's going to provide us with a lot of the functionality we need to make sure that, well, we know how to talk to the engine and we know how to work with it at the appropriate times. If we hold the Control key, you'll notice that this becomes a link. And if we left mouse click on it, it'll actually open up a list of all the different public methods that we have access to. Importantly, you'll notice that it's defined within the namespace Unity Engine. That's why we are using Unity Engine. And once again, you can go through and look at these and see all these interesting methods that at the moment mean nothing to you, but will mean something by the end of the course. Here we have our class declaration again. MonoBehavior inherits from a class called behavior. Didn't we see something in that warning about a behavior not working properly? Now you know why. It turns out that's a parent class. We're getting functionality from behavior. Whatever was processing our object was expecting a behavior to work with, and it did not find it. Let's go ahead and Control click on that, and what do you know? There's another parent class here, this time called component. All right, well, let's click it again. And this time, now we see there's another parent class. Now, component has a tremendous amount of features, as you can see here. All kinds of interesting methods like get component or get components and sending messages and so forth. But what we care about is getting to the end of this chain. And finally, here we are, public class object. And here you can see quite a lot of different methods and features we could use with our object that we inherit and get to work with. Now let's close that and come back here. Within the class, we also have methods. Now these are special methods. They're called event functions inside of Unity. What that means is that at the appropriate time, Unity will call these methods for us automatically. For instance, here you see that start is called before the first frame ever gets rendered and before update. We don't get a constructor inside of Unity because Unity is taking care of everything for us inside of the engine. What we get are specific functions that fire at specific times, and we can fill them with whatever code we want to make our stuff do, well, whatever we want it to do. So start for us is a great chance for us to initialize variables or maybe check things, whether or not we have access to the things we need to, or see if anything's missing. Then we have update. Update, this function here, gets called once per frame. Most people don't realize that in a real-time application, when you code, you're actually coding for each frame. That is, you are making minor, small changes, maybe 60 or 90 or 120 times a second. So this update method, if your frame rate was 120 times a second, would get called for this specific component 120 times. Update is going to be responsible for, well, pretty much anything interesting that we want to have happen. That is, if we need something to be checked every frame, say keyboard input or maybe a state change or something else in our scene, inside of update, we'll get a chance to do that 30, 60, 90, 120 or more times a second. There's more than just start and update. There's actually a giant extensive list of different event functions inside of Unity. For instance, there's actually an event function called awake that happens before start. So I could do void awake and hit enter, and you can see it fills that in for me. Awake occurs when the instance is being loaded. That is when the scene itself is being loaded and is one of the first things to happen. We simply have these set methods or functions that we get to put our code in, and we can reliably know that they get called at certain times. Same thing with update. For instance, there is void fixed update. Fixed update is, well, fixed. That is, you can always expect it to happen at a set time with a set interval between each update. Whereas update is frame rate dependent. If you've ever played a game before, and let's say you go into a new location and there are 1,000 enemies on the screen, you'll notice that your computer might chug a little bit. That is, you might drop in frame rates. That means that your update isn't being called as frequently as it was before. Therefore, it might happen 59 times on 1 second, and then it might happen 30 times on another second. Because it's variable, you can't depend on it always happening when you want it to. You actually have another update called late update. Now, I'm not trying to scare you. Unity has provided you with a lot of different event functions. Most of the time, you don't need to use them until things get a little bit more advanced. So for right now, let's delete them. Just file it away in the back of your head that there are more event functions than you see here. Now, if we go back to Unity and take a look at our GameObject that we attached test to when we went ahead and created it, you'll notice that we have a script and test, but we don't have anything interesting here. If we look at other components like the mesh renderer or the sphere collider, we have all these different things that we can change and manipulate, but we have nothing here in test. So let's add some things that we can manipulate. Go back to your script. What we want to do is add some member variables. That is, member variables that are public or with the attribute serialized field will show up in the inspector. The inspector will remember what values you input inside of Unity. They can tweak the different values that you expose. So it's always a good idea to expose different values that will allow a person to better control it. But don't go crazy. Don't expose everything. Let's do a public boolean. And let's just say is animating. Not that we're animating anything yet. We can leave it like that if we want to, or we could give it a base value. Let's just say is animating is false for now. It's not going to animate. Let's try something else. Let's do public float. So a floating point number, decimal number with 32-bit precision. Minimum value is equal to, let's just say minimum is 0.0f. By the way, yes, you need to put an f on the end of your decimal numbers when dealing with a float. If you don't, you'll end up with this error saying that this is a double and you're trying to put a 64-bit version of this number into a 32-bit version. And let's do something that's not public. Let's do private int you can't see me. How about that? Is equal to 1. Let's go back over to Unity and see what shows up in our inspector now. Here we can see that test now has is animating, and it automatically gives us a checkbox to indicate true or false. Also has minimum value, and here you can see that's set to 0. We could also click and drag this, and what you'll notice is that this value is going to update to whatever we see here. Now, an important thing to understand is that if you change the value here, let's say minimum value is now 5 instead of 0, and come back over here, what you'll notice is that minimum value is still 0. So we can change this all we want to, but it's still not going to match up with what's here. If you want these two to match up again, click on the ... and hit reset, and it will reset these values to whatever was inside of the script. At the moment, "you can't see me" is private, which is why we can't see it in the inspector. However, C# has what are called attributes, but it's pretty much using a bracket if we have the attribute serialize field, and you can see it auto-completes and shows you different ones. What serialize field lets you do is if you declare this above a variable, it's going to expose it inside of the inspector. So here you can see now that yes, we can actually see that value and we can manipulate it if necessary. Now we can see that we can add basic variables, but Unity actually has other variables built into it that are pretty interesting. For instance, we could declare a public color, let's just call it color, is equal to, let's say, color.red. And then let's say public vector3, my vec, is going to be equal to, let's just say, a vector3.0. That is a vector with the x, y, and z component all set to 0. There are many, many other types as well. I just wanted to show you that Unity has different classes with different types to help you do 3D graphics and programming. Now, a color is a value between 0 and 1 for the red, green, and blue channels. Now let's take a look at those in the inspector. Here we can see that a color gets replaced with a color swatch, which we can choose and manipulate however we want to. Very convenient. Then we have a vector, and instead of us declaring 3 different values or an array of size 3 for floats or doubles, it gives us these values automatically that we can manipulate. We've covered a lot here in this video, but let's actually do something of interest. So I'm going to go ahead and just delete these variables really fast. What I want to do is create an oscillating or a pulsing sphere. I want to make it so that the scale of any game object that we put this component on will get bigger and smaller. When we create scripts, we're not just creating it for one object. This script can be reused across any objects. When you're designing your scripts, think about how to make them as universal or general purpose as possible. So let's create 2 different vector3s. Let's do a public vector3 called min for minimum. And also let's do a public vector3 called max. Min and max will represent the range, that is the possible scales the game object can have. Minimum will be the lowest, maximum will be the highest. Now if I hit Control Save, and when you hit Control S, if you take a look at test, if you didn't save something, like if I were to delete a line, you'll notice I have a little asterisk on the end. That means we have unsaved changes. Make sure you hit Control S or go to File Save before you go back to Unity. Now, if we come back to Unity, what we'll notice is, and it might take a second, is that the test script updates and we have a min and a max value and different floating point numbers we can enter in each. Now, what I envision us having happen here is that we're going to have our game object, and I want the scale to go between the minimum and maximum value back and forth, back and forth, and back and forth, oscillating for as long as the game is running. So we can do this by using a function that naturally oscillates between 2 values forever, such as sine or cosine. Sine will provide us with values between -1 and +1 for all values passed in. However, I plan on using a special function called LERP. Now, when I mention a function, and if you don't understand it, let me show you how you can use Unity's documentation to find out more about it. So if we go back into Unity and go to Help, Scripting Reference, it'll bring up a website. What I want to do is type in the method LERP. Now there are several different versions of LERP, but the one I want to work with is called mathf, for math floating point numbers, .lerp. LERP takes in 3 values and returns to you a floating point one. It takes in a start value, an end value, and what you provide to it is a value between 0 and 1. And when it's 0, it will be value A. When it's 1, it will be value B. If it's 0.5, it's exactly halfway between A and B. It's linearly interpolating between 2 values. Now, math.f works with floating point numbers. What I really want is vector3.lerp. And if you'd like to, it actually explains the equation behind how this works down here, as well as an example. Now, back to our script. What we know we want to do is 1, use sine, 2, use lerp. The problem is sine goes between -1 and +1. LERP wants a value between 0 and 1. So we need to format or transform the output of our sine function to work in the range of 0 to 1 instead of -1 to +1. So to do that, if you think about it, if sine goes from -1 to +1, we can just, well, add 1, in which case our range is now between 0 and 2. And if we then multiply that by 0.5, we have our range, which then becomes 0 to 1. Now, the last piece of the puzzle that I need to explain to you is, where does this value go? How do we access the scale of our object? It's within the transform of the object, and the transform has a position, rotation, and scale value we can manipulate. So over here, let's just type in transform, dot, and you'll notice autocomplete is going to help us out here. And we can just scroll up and down, and we can see local scale. Sometimes you won't know that transform exists. How do you find things if you don't know they're there, especially as a beginner? When I need to figure something out and I don't know it, I always start with this, which is the instance we're dealing with of the class. So this instance, dot, and then you get the autocomplete, which tells you all of the different methods and things you can access. And there we go. There's transform. Let's do dot local scale. And you'll notice it even tells you that local scale is a vector3 type. So we'll do local scale is going to be equal to, and now we need to process everything. So we know the last thing we're going to do is we're going to LERP between our minimum and maximum value, right? So we'll do vector3 dot and then LERP, because that's the method. So we need to pass in our min, which we already have, and our max, which we already have, but we have to pass in this t value. Well, let's just put a placeholder there for right now. So we need to calculate t. How are we going to do that? So LERP takes in a float, as you can see. So we're going to create a float. So float t is going to be equal to, t is going to be the result of our sine, right? So sines and other math is under mathf dot, and then we have sine. And then we put a parenthesis in there and we get some information on the method so we know how to fill it out. It's expecting a floating point value. Well, we know that the mathf.sine needs to be transformed, right? We needed to add 1 to it. And then after all that's done, we also needed to multiply it by 0.5. Once again, put an f on the end because we're dealing with floats. But what are we going to put in sine? We need a value that is going to continually increase as time goes on, right? And there are several ways to do this. We could create a value called float current time and set that equal to 0.0. And then in update, we could increase this by some arbitrary amount. But it doesn't need to be arbitrary. In fact, what we could do is Unity provides us with the current time using the time class. If you type in time, you'll get all these different ways of manipulating time. There's delta time, which is the amount of time that has passed since the last frame. And since it's in seconds and we update very quickly, that's going to be a very small number. So we could use delta time, current time, plus equals time.delta time. That's fine, but why should we keep track of that information? We could also use the recorded time that Unity already stores. Remember, we could do time dot, and then we take a look and just read the different definitions here. There's also time.time, the time in seconds since the start of the game. Well, the game's going to continue and continue until we end, so that value is just going to get bigger and bigger, so why not just use that one instead? So now we have a float value that's going to take in a number that continues to get larger. Sine is going to produce a value between -1 and +1. It's going to become a value between 0 and 2. Then it's going to be halved to a value between 0 and 1. And we're going to use this value here to calculate the LERP, or linear interpolation, between our min value here and our maximum value here. Now, we don't need current time anymore, so why don't we go ahead and get rid of that. Now let's go ahead and see this work by going back into Unity. Nothing's happening because, one, it's on an empty game object. And while an empty game object does have a scale, it has nothing visual representing it. Therefore, while these values will ping pong, nothing's actually going to be visible. Why don't we go to our sphere instead? And what we want to do is attach this new component. We could go to add component, or what we can do is, I'm just going to make these smaller, we can click and drag our object over here and add it to our stack of components. Go ahead and open that up, and let's say minimum, 0 is fine, and our maximum, let's say, is going to be 10, 5, 40. Why not something crazy? I'm going to zoom out a little bit because it's going to take up a lot of space. And what we need to do is press the play button for our script to run. And oh boy, remember that the game view right now is over here on the side. So when I hit play, it's going to pop up and replace it. Now I don't usually like to work this way, so what I am going to do is I'm just going to drag my game view down to the top so I get a nice little split screen, and I'll hit run. And you can clearly see here that our sphere is growing in size based upon these values here. And we can manipulate these in real time. However, do understand that any changes you make to the values as this is running will not be saved. So if I really modify these values to something crazy, like negative ones, and I hit stop or the play button again, what you'll notice is that all the values in the inspector return to the way they were. You will lose any changes when play is running. So make sure you make changes, you test things, but if you want to remember them, either write them down or click here and copy those values and paste them later. Now when I hit play, what you'll notice is that the screen darkens a little bit, but it's not really easy for me to know that I'm in play mode. What I usually tell most beginner students to do is go to Edit and then go to Preferences. Then go to Colors. Here you'll notice there is under General the Play Mode tint. When you're first starting off, I highly recommend turning it to something incredibly obnoxious, like this bright red. And what that means is when I hit play, the menus will turn bright red, giving me a huge warning that if I make changes to my components, they will not be saved. I've seen far too many people make the mistake of running things and forgetting that it's running, making changes to their scene, changing where the objects might be, their directionality, and everything else. And then when you press play again, it all reverts back to the way it was and you lose all of your changes. Change the color of your screen during play mode so you know that you won't lose any information. So that's it for the very basics of components and creating your own simple script. Within each lecture, we'll be learning about lots of different components inside of Unity, how to manipulate them and create our own to do all sorts of different effects.